Hi, my name is Justine Harkness, and in this video we'll look at some of the factors that lead to the favoring of either an SN2 or an E2 reaction pathway. And determining SN2 versus E2, there's actually several trends that we need to investigate, and we're going to take a look at these with a table. So we're going to look at the substrate and the nucleophile on the base, the solvent, and also just look at what we would get out of the reaction. So for an SN2 reaction, what we really want is an unhindered substrate. So we can see methyl or primary for SN2 pathways, whereas it comes to E2, it'll work with primary, secondary, or tertiary, just not methyl. And not methyl because if you only have one carbon, you cannot form carbon-carbon double bond. Now for the nucleophile, in an SN2, you want to have a strong nucleophile that is unhindered. So something like, chloride or hydroxide, both of those are strong nucleophiles, but they're very small, so it's really easy for them to come in and attack the backside of the substrate. For E2, you need to have a strong base, and if it's bulky, that will go even further to favor an E2 elimination. So something like this base, it's very bulky, and because of the oxygen with the negative charge, it would also be a strong base. For solvents, both SN2 and E2 want polar aprotic solvents. For SN2, we want aprotic so it doesn't hydrogen bond with the nucleophile, and for E2, we want aprotic so the base can't deprotonate the solvent. And finally, looking at the products, with SN2, you will see a substitution, and it will invert the stereochemistry. With E2, we'll get elimination and a formation of the more substituted double bond. So let's take a look at an example, and we're going to evaluate all of these factors as we look at it. So here we have a scientist with the following reagents, and let's just draw out our reaction pathway. So we have our substrate. This is a secondary substrate, so it's fairly hindered. As our base, here we have this sodium butoxide. This is a very strong base, and it's also very bulky. And for our solvent, we have acetone, and this is a polar aprotic solvent. So considering the different factors, if we have a secondary substrate, that's not very good for SN2. So not good for SN2 because it's a little bit too sterically hindered. When we look at our nucleophile slash base, this is a very strong, bulky base. This is good for an E2 pathway. So because we have a fairly sterically hindered substrate and our base is both strong and bulky, this would favor an E2 pathway. So we're going to eliminate and form a double bond. So now you should feel more comfortable evaluating the different factors involved in E2 and SN2 and predicting the product of the reaction.